Hello, this is a short video highlighting experiential learning during the first 2 weeks for a course in physics for high school students. You will find video links for full classroom sessions in the description of this short video. Thank you.
So here you see this is the source, this is the point of incidence, and there you see the reflection of this. There you see the image of this, and this is a screen to collect it. And then, the light will travel from the source to the mirror along straight line path. And yesterday we have discussed this. We call this as rectilinear propagation of light. So what is rectilinear propagation of light? Yes, light will travel in straight line in homogeneous optical medium. I suppose you understood what is the homogeneous optical medium. From here to this point. This light is traveling from this point to this point. Right? This is the, what is this? Points of incidence. This is the point of incidence. Right? Then you see this real, and of course there was a perpendicular. So what we measured here was, what did we measure here? We measured the angle of incidence, this is angle of incidence, this is angle of reflection. Okay? So this is what we have identified. Tell me what is the image distance? Why?
Same object is used to measure. You can see the same object. So in the mirror world, you can see.
So whatever this tip, the tip of this and the tail of this. The tail of this is on the mirror, and the tail of the image of this is also on the mirror. And the tip is touching this object, and the tip of the image of this is also touching the image. Yesterday we have seen that we had kept an object in front of a mirror and we got its image, and practically we measured practically what we got. Practically we saw that x is equal to y. Now we have to prove x is equal to y geometrically. Okay. So what I have done here, I have drawn the mirror, and then this is the incident ray, this is the reflected ray, and this is the mirror, plane mirror. And now what we have is the object is here, the image is here. And I don't know, I have just arbitrarily said the distance of the image is y, and I have told the distance of the object is x. I don't know, x is equal to y or no, I don't know. Practically I have proved it is equal, but now I don't know, I have to prove it geometrically. Now what is that I know? I know what the laws of reflection. So accordingly I have presented the incident ray, the reflected ray, and the normal. I am great, I am established. Then when you feel ahankar, you are lost. Okay? So therefore it is the wrong answer that created humility in me. So don't do that. Done. Did you understand this?
So how is it corresponding angles?
Which two?
Angle of incidence.
These two. See, this angle is 90, this angle is 90. This angle is 90, this angle is 90. So these two lines are parallel. This line and this line are parallel. Right? And then this is a straight line. This is a straight line, IM. And therefore this angle will be equal to this angle. Here I is equal to R, I is equal to R, and R is equal to I. Okay. Good, correct. Great. So I have used all the laws of reflection and the geometry. This is called geometrical models. Malum ho abhi? ठीक है? Good. Any other questions here? No questions? Right. Any other thing you want to know about a mirror? Now you see, if I have taken some ray, see here I have taken arbitrarily. I have just drawn one line here. You can do this with any other line, and you should still get the same result. You should do this any other line, you should get the same result, and it's quite possible. Okay. Right. Provided I have drawn this angle correctly, line will meet this.
Perfect. Okay? Like that you can. Right? Now I can give you one. Have you understood how it is? Geometrical optics? You want to learn more? You want to prove that you are intelligent? You want to prove or no? Or you don't want to prove? No, no sir, right now we don't want to prove. Afterwards you prove. Shall I give you one small numerical? The ray of light is incident perpendicular to the mirror, isn't it? It is incident perpendicular to the mirror. Okay, all of you can see that? And answer. Now I am going to tilt the mirror. Okay, this line, this center line, 0. You must treat it as a normal to the mirror. Okay, so going in the same direction. Okay, now I can change the source or I can tilt the mirror. Both are one and the same. Okay, incidence is, what is the angle of incidence? Can you see the angle of incidence?
10
Louder.
degrees.
10 degrees. Okay, and you can see the angle of reflection. That is, this is the incident ray and this is the reflected ray. Okay, so you can see that this angle is 10 degrees and this angle is 10 degrees. The laws of reflection you have now understood by experimentation. Theoretically also you have learned it. Okay, now I will show you one more. Sirish, are you able to see? Hello.
Yes, sir.
Yes, Sirish is attending online. Now you can see here, I have got one mirror here, right? And then I have got one more mirror here. Now what you see here is a small setup. So I have a lens here, right? So here behind the scale I have got a lens, and then there is a scale here to measure the object distance and the image distance. Experience the reality. Right? That is why this experimental setup, what you are seeing here. Understand? You must experience the reality. So you can feel the truth. Now you see what I have got. I have got a concave mirror here. I have got a concave mirror here. And you can see there are 3 parallel rays of light. Can you see?
Yes, sir.
Louder.
Yes, sir.
And then you can see all of them are converging at a point. Right? So this ray is traveling along the principal axis. Students, in the last class we have understood the concave mirror and the formation of image when the object is placed beyond the center of curvature C, between F and C, and F, between F and P, and so on and so forth. Okay, and now what you are seeing on the board right now is a consolidated diagram. Okay, what is this consolidated diagram? Let me explain to all of you. Okay, now you see that I have placed an object and this object. There are 5 quantities: H O, H I, U, V, and A. These are the 5 quantities. Now, from whatever experiment we have done, and even the practical experiment and the theoretical experiment, what we have found is that V, this is another function, right? Name of another function. Now, our job is to determine these functions. Our job is to determine these functions. What are these functions? See, what are these functions means, is V equal to U, is V is equal to U plus F, whatever it is. So, we need to understand, we need to derive the relation, determine the relation. Okay, so that is our next task. Clear, students? So you have to understand. I'll give you some time. Just look into it. Okay, then we shall proceed. I suppose you understood this diagram. Very important. You see, if my left hand is telling object image, right hand is showing the object. So you can see the image is here, the object is here. As the object is moving closer to the mirror, the image is moving away from it. Okay, see this, what is happening, you should be able to imagine it. See, in the numericals that you are going to solve, we are seeing this, different positions, right? Yesterday we have taken some picture. Now what do you see in front of you? Come on, Fatabat you tell, then things will move fast. What do you see in front of you? Hello. Yes. So you see a mirror and a mark. Okay. Good morning, friends.
Good morning, sir.
So we are going to conduct an experiment to understand another phenomena of light. We have learned one phenomena of light, that is reflection, right? And you know, when light is traveling in an optical medium, if it strikes the surface of another medium, then you see the light is traveling in optical medium air, it is striking the surface. So what you see here is a piece of glass. This is a piece of glass, right? And there is a line marked on this. This line is perpendicular to this edge. This is a rectangular glass piece. Okay. Now, what you see here is a ray of light is hitting this point, right? 10 degrees. So the incident angle is how much? 15 degrees. The reflected ray is 15 degrees. And this angle made by the refracted ray with the same normal, you can see the same normal. You are measuring the incident ray with the same normal, and with the same normal it is making 10 degrees. Hello, are you with me? So this incident ray should have traveled straight, but now it is bent towards the normal, and therefore this angle is 10 degrees. Hello?
Yes,
sir. So the angle of incidence is 15 degrees, angle of incidence is 15 degrees, angle of refraction is 10 degrees. So otherwise this ray of light would have gone straight, and then this ray, if it had gone straight, it would have made an angle of 15 degrees. Since it has made 10 degrees, what does it indicate?
The angle of refraction is less than the angle of incidence.
That is the measurement. What does it mean?
Normal. The angle of refraction is not equal to angle of.
Okay, angle of refraction is not equal to. See, you should. I am training you to tell maximum truth. You are not trying to tell maximum truth. Some truth you tell and you feel it is nice. Try to tell. See, when you are having a measurement here, why you want to say this angle is less, something less than, more than? You tell no. This angle of incidence is 10 degrees. This is 15 degrees. So angle of refraction is less than angle of incidence. What does that mean? What do you infer from that?
I wanted to know that what is the distance between the lateral shifted ray, I mean the emergent ray and the normal. For
okay, now you see what you do. You draw a line from here.
Yes.
Good question. Huh.
What if the class is not
Talk, speak loudly.
normally she's asking. If a
Students are conducting experiment. Good. And you can see the experiment on the screen for wider view. If you have any questions, you ask.
or the normal?
So both are there. So you have some questions which I can clarify it when I now you have observed there is a lateral shift. Now I will go to the board and draw whatever we have seen, right? And then it will be easy for us to analyze and understand what exactly you mean by lateral shift. Okay? Right? So if you have completed experimentation, we'll go to the board. Okay? Happy?
Yes,
Friends, just now we conducted an experiment. See, the process is like this. We have to conduct experiment and try to see what really happens. So we have seen the phenomena actually taking place.
Now we need to analyze, right? So we have observed. So the next step is analysis. So whatever we have observed and we want to analyze, so we put it in this format. So as you can very well see, refractive index. So refractive index is a figure of merit which will tell you how much will the light bend. Of education, wherein we complement and supplement the academic curriculum of the students belonging to the high school section.
When we put this subject in motor, sir,
Huh.
buoyant force is acting on.
Yes. So how much is the buoyant force?
1 Newton.
Correct, 1 Newton. Understood? I didn't teach you. See, this is called as observing and learning. So now you see, you can measure the buoyant force. So simple physics. Correct? Any question?
No, sir.
Did you go through the textbook yesterday? Now starting from the first sentence, do you have any issue with any word, any sentence in the textbook? No. If you have one, you should immediately ask. Okay? Carrying current I in the upward direction. A pen ಮೇಲೆ perpendicular ಹಿಡಿ. ಪೆನ್ನಿಗೆ ಪೆನ್ ಮತ್ತು ಬುಕ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಬೇಕು ಅದಲ್ಲ. ಈಗ ನೋಡ್ರಿ, ಇವಾಗ the magnetic field will be, if you draw the magnetic field, you will draw it on the plane of this book. What happens? Is the direction of right? ಇದು magnetic field, ಇದು compass needle. Compass needle the deflection ಇಷ್ಟು. ಯಾವ್ದಾರ NTSC ಅವೆಲ್ಲ ಎಕ್ಸಾಮ್ ಬರೆದ್ರೆ ಅವಾಗ ಇದೆಲ್ಲ ನಿಮ್ಗೆ ಯೂಸ್ ಆಗುತ್ತೆ. 21.8. You wrote 53 point something, no? Good. ಈಗ ನೆಕ್ಸ್ಟ್ ರೀಡಿಂಗು ಇಲ್ಲಿ ಬರಿಬೇಕು, ಇಲ್ಲಿ ಬರಿಬೇಕು. Understood? So both of them were moving with
Container is at rest because there are two forces acting on it. The gravitational force, which is downward in direction, and the tension force, which is upward in direction.
You will find links for short videos in the description below to understand this system.